Good morning. I'm Vinitha, Associate Professor in the Department of Electrical and Electronics Engineering, RMD Engineering College. Today I am going to discuss about one of the switching transients like capacitance switching. So let us discuss what is meant by switching transients. So switching transients are nothing but a sudden change occurs in a circuit, especially during switching operations like closing and opening of any switches or any circuit breaker contacts. And this switching over voltage, which is one of the internal cause of the power system. Let us see the different causes of switching over voltages. So first, when a no-load transmission line which is suddenly switched on, the voltage on the transmission line becomes twice the normal system voltage, and this voltage which is transient in nature. Similarly, when a loaded transmission line which is switched off or interrupted, the voltage across the line becomes high, causes over voltage in the power system. Similarly, during insulation failure, a live conductor which is suddenly earthed. This also may cause a sudden overvoltage in the power system. So these are all the various causes of switching over voltages in power system. In this, already I have discussed about the inductance switching, that is current chopping. Today I am going to discuss about capacitance switching. So the another cause of excessive overvoltage transients in the power system is capacitance switching. Here, such capacitance switching may occur while energizing and de-energizing the shunt capacitor banks and routing of unloaded overlines or underground cables, etc. And in power system, the shunt capacitors are employed to correct a lagging power factor, or in some other cases, it may use to improve the voltage in the system. In some applications, they are switched in and out frequently as the system load varies and the system fluctuates. So normally the shunt capacitors are included in the power system to improve the power factor as well as to increase the system voltage, and this is called as capacitance switching in power system. During capacitance switching, the magnitude of the current for different cases are given here. For an unloaded transmission lines, the charging current that may up to that may change up to 10 amps. Similarly, for underground cables, the charging current may increases up to 100 amps, and the capacitor banks the currents that may lead to 1400 amperes. So these are these are under various cases change its capacitance current. Now, let us discuss what is mean by capacitive switching. So, this capacitive switching that requires special attention because even after the current interruption in the circuit also, there may be a presence of electrical charge that may cause a dielectric reignition of the switching devices. When the process repeats, interruption of capacitive current causes higher voltages. So while doing the capacitance switching, we should ensure that whether all the charges are diode from the system. Otherwise, it may cause the higher voltages in the power system. Now, to analyze the capacitance switching, we can have a simple equivalent circuit of an unloaded transmission line. And this is shown in this figure. So this is the example for this capacitance switching, the circuit which consists of inductance and capacitance along with the switch, and the circuit which may be energized by an AC source. And here, in this here, there's a voltage and current waveform during the capacitance switching, which is given here. So the first diagram, that is the first waveform that shows the normal voltage and current waveform during the capacitance switching. So here, so in this actually, so in this waveform, First waveform is nothing but voltage waveform, and the second waveform is nothing but the current waveform. See here, so this one is the voltage waveform. The second one is nothing but the current waveform. So here the current leads the voltage by an angle of 90 degrees. So this is the first waveform. And the second waveform, it is drawn between the capacitor voltage with respect to time. So whenever the circuit or the circuit breaker contacts are in close position, the normal current will be flowing through the circuit, and the capacitor will starts to store the energy. So this capacitor voltage, this will follow the normal supply voltage. So here this position normal supply voltage. Here you can see from this point it is a normal supply voltage, and after this point, after this positive half cycle, the voltage that leads to negative half cycle. At this moment what will happen? The value of current becomes zero. So if the current becomes zero, the circuit breaker contacts get open. Only during open circuit condition only what will happen means the current value is equal to zero, and during that instant the capacitor will not charge, and so this voltage remains constant. So whatever the voltage available in the capacitor, that will be existing in the system, and during that instant, if you draw the voltage across the switch, if you see here at this instant, if you draw the waveform here, there is a sudden increase in voltage, because now what will happen? The switch gets open. The circuit breaker contacts are in open condition, and so that during open condition there will be a rise in voltage. Okay, so that is given in this diagram. So during this condition, the voltage across the switch, it may increases to twice the value of the system voltage. So, and here, from the diagram, we can see that in the voltage across the circuit breaker, that becomes higher than the normal system voltage. So this condition, which is called as Ferranti rise or negative regulation, that is this load side voltage that will be greater than the value of the system voltage. So that will be termed as Ferranti rise or negative regulation. Now, let us discuss during this switching what will happen. So if the capacitance or inductance present in the circuit continuously, there will be a restriking of an arc takes place. So let us see how the restriking occurs, how it will be completely damped out. So consider a restrike takes place when the voltage reaches its peak value. So when the voltage reaches its peak value, what will happen? There will be the current in the circuit that is equal to zero. So during this instant, the capacitor voltage, which is subjected to an sudden oscillation due to the disturbance occur in the circuit. Now the frequency of that oscillation, which is given by F naught, is equal to omega divided by 2 pi. This can be written as 1 by 2 pi square root of LC, where L is the inductance of the supply and C is the capacitance of the capacitor bank. Now, the restrike current will be the instantaneous voltage across the switch divided by the surge impedance. Here, in order to calculate the restriking current, the formula is given, that is the voltage across the switch divided by the surge impedance. Surge impedance formula is nothing but square root of L by C. So the formula is nothing but 2 into V into sine omega t. Vp is nothing but the peak voltage. So during the opening of the circuit breaker, the voltage that may increases to twice the value. So the voltage becomes 2 into Vp into sine omega t divided by square root of L by C. So this can be written as 2 Vp into C by L the whole power 1 by 2 into sine omega t. This is the formula which is used to calculate the restriking current in the power system. Now here, during this capacitance switching, how the restrike occurs and when it appears in the circuit, that is shown in this figure. So first diagram, if you see, which is drawn between voltage and current. So this is the normal source voltage and this is the capacitance voltage. So whenever there is a whenever a circuit which is in normal condition, the current will be flowing through the circuit, and so we will get the normal voltage waveform, and so the capacitance will be in charging condition. So if you see until this point, the capacitance that will be in charging condition. So whenever the source voltage that is maximum position, what will happen immediately? That is during this instant, actually the current becomes zero. So at this instant, what will happen? The circuit breaker contacts are again reclosed, and so that what will happen? There is a restriking of an arc takes place. So when the restriking of an arc takes place, it will be due to the presence of capacitance in the circuit, because whenever the circuit breaker contacts try to open, immediately it cannot able to open because there is an enormous amount of charge that will be present in the circuit. So whenever the charge that in the available in the capacitor that will be fully damped out or dies out, then only we can say that the circuit breaker contacts that will be fully open condition. And during this condition, during this restriking condition, the capacitor voltage that may leads to three times the value of the supply voltage. So during this restrict, what will happen at this instant? So here initially there will be an occurrence of restrike, then again it will be zero. During this zero condition, zero means circuit breaker contacts are open. The striking, that is restriking of arc, this will not continuously occur. So restriking means that is the presence of arc. Then immediately it may get turn off. Then again there will be a restriking of arc. Again it will be goes off. Similarly, this process that may continues until all the energy in the capacitor that will be dies out. Similarly, at this position, what will happen? The current becomes zero. So the voltage is maximum. So during this first peak, the voltage across the capacitor that may increases to three times the value of the supply voltage. So after some period, that is after all the energy stored in the capacitance that will be dies out, then the system that will be comes to the normal steady state condition. So here this is the waveform that is drawn during the capacitance switching. Now here the waveform which is drawn between voltage with respect to time during restriking. So the first waveform is nothing but normal voltage and current waveform, supply voltage and supply waveform. So initially here this is a normal voltage and current that follows for the capacitor circuit. Current leads the voltage by an angle of 90 degrees, and whenever the voltage that reaches, so first initially this is the voltage, and whenever the supply voltage is there, there is a presence of capacitor voltage, because the capacitor that will be continuously charging. At the same time, what is the value of the voltage available across the breaker? It becomes zero, because breaker is in um, uh, closed condition. So during the short circuit condition, the voltage across the breaker that is equal to zero. Now at this instant, the supply voltage that goes to negative cycle. So if this supply voltage that comes in the negative cycle, the capacitor voltage that also leads to negative half cycle. So at this instant, if you see the supply current that becomes zero, source current that becomes zero. If it becomes zero, what is the meaning? The circuit breaker contacts get open circuit condition. So during this open circuit condition, what will happen? The capacitor, there is no current flows through the circuit, and the capacitor will not charge, and so the voltage across the capacitor that becomes constant, because here the circuit breaker switches in the open condition, no current flowing through the circuit. So whatever the voltage that already exists in the capacitor, that will be available across the circuit, across the capacitor now. So at this instant, what will happen? The voltage across this voltage across the circuit breaker will started to increase, because now the circuit breaker which is in which starts to operate. Okay. So during this instant, the circuit breaker, the voltage across the circuit breaker will starts to increase. Now till the first point, first restrike, there is an increase in voltage. Then what will happen? Again, there will be a restriking at this instant when the voltage reaches its maximum peak. there is a restriking of an arc takes place. So during this restriking, what will happen? Again, for a moment, the circuit breaker contacts get closed, and so that there is a flow of charge for a small period. Then again, what will happen? The fault has been cleared, and then again the normal condition that will be restored. After some moment, again what will happen? There will be a second restriking of an arc takes place. This will happen for a small period. Then again what will happen? Again C2. C2 means again clearing. Similarly, continuously there will be a restriking of an arc and the clearing of an arc takes place until all the energy in the capacitance that will be damped out from the circuit. So this will be called as capacitance switching in the circuit. Thank you.